All right, this is the video for section 5.2 that talks about binomial probability distributions. So that is one distribution that describes discrete random variable is binomial distribution. There's another one, Poisson, that's the 5.3, but we don't cover that. Okay, so this class will focus on just the binomial probability distribution. Okay, then objectives at the end of this, you just should be able to describe a binomial probability distribution and find probability values for a binomial distribution using a formula, a StatCrunch, or the table. Okay, you will need this table A1. So if you don't know, go to the files and go to tables, and that's what you need for this section. Okay, the second is to be able to compute the mean and the standard deviation for the binomial distribution. So take note of that. Whenever we have a distribution, we can always find the center and then the spread, mean and the standard deviation or variance. Okay, and then use those results to determine whether we have a significantly high or significantly low or significantly high. All right. Now don't forget we can also use probabilities where we consider the probability that X or more is less or equal to, say, 5% or sometimes 1%. Okay. So first, what is a binomial distribution? What's a binomial random variable? It has some characteristics, and there are 4 of them that we need to know. So when you define your random variable X, what are the criteria, okay, for that? Okay, the procedure, that experiment has a fixed number of what? Number of trials. So that means that a trial, of course, is a single observation or single performance of an experiment. So it has a fixed number of what? Number of trials, which is very important because if you're talking about discrete random variable, then it has to be countable. All right. Then the second criterion is that the trials must be what? Independent. Okay, the trials must be independent. What do we mean? That is what? It is what? With, so take note of that. With what? With replacement. Okay. Okay, if it's with replacement, it is what? It is independent. If it is without replacement, that is what? Dependent. Okay. When you say independent, that means the occurrence of one is not influenced by the other, or occurrence of one no, is not the other that's not influenced by something that happened before. Okay. Third, each trial has exactly 2 outcomes. It has a success, which we're going to denote by the letter S, and a failure, we denote by a letter what? F. Okay, 2 possible outcomes, a success and a failure. Now take note of that. A success doesn't mean it is good. Okay, and or a failure doesn't mean it is bad. Okay, it depends on your goal. What are you looking for? So like in 5.1, if I'm looking at the number of heads in tossing 2 coins, okay, my success is whenever I have a head. Okay, and a tail is when I have what? A failure is when I have a tail. Okay, so take note of that. Then the fourth thing is that the probability of a success remains the same in all the trials. This is because these are independent what events, so your probability of a success will always remain the same. Now in this class, there's a notation. The probability of success will denoted by what? A letter P. And then the probability of failure will be denoted by a letter what? Q. Okay, as we see in the next example. All right, so now it says that the experiment represents binomial experiment or binomial distribution. Okay, the Y-sort method of sex selection developed by the Genetics and IVF Institute was designed to increase the likelihood that a baby will be a boy. So take note of that. A baby will be a boy. Okay, when 160 couples use the method and give birth to 160 babies, the sex of the babies is what is recorded. Now, this is exactly the homework 5. Homework number 2. Okay, so if it describes a binomial distribution, then it has satisfied the 4 requirements. Okay, the 4 requirements, what are they? 1, let's go back. The procedure has a fixed number of trials. The trials are independent. It has exactly 2 outcomes, a success and a failure. And then the trials, the probability of success remains the same because the events are what? Independent. Okay, so from this, what's the first requirement? Okay, that has what? Fixed number of what? Trials. Okay, now there's a procedure, it has what? Has fixed what? Number of what? Babies. Okay, number of trials, because there are what? 160 couples. Sorry, 160 couples. So there are what? 6 number of what? Trials, because here we have what? Sorry, 160 what? Couples. Okay, so that's a fix. In this case, this would be your n. And then 2, it says that the trials are what? Independent. Okay, each couple, because each couple is what? Independent. Is independent of what? Of the other. Each couple is independent of the other. So because of that, the trials, meaning that the trials, okay, are what? Independent. The trials are independent. Okay. Then 3, it says that each outcome has what? A success. Okay. So each trial has 2 outcomes. What are the 2 outcomes? Each trial has exactly what? 2 outcomes. Now, what are the outcomes? Okay. A success is when you get a boy. So success is when you get what? A couple gets a boy. And then the failure, okay, is when we get what? We get a girl. Okay. So it has 2 possible outcomes, a boy and a girl. And then 4, okay, the probability of getting a boy and a girl is what? It's made the same, because the probability of the success is not affected by what? The previous the probability for each success is what? Is the same. All right, because you get a girl, boy, or a girl is what? Is 50-50. Okay, so here we have the probability of what? Of success, all right, is same. It was same for what? For each trial. Okay, because that probability is going to be what? 0.5 for 50-50. Get a boy is a 50. Okay, so therefore we say that this experiment is what? A binomial experiment. So it is a what? A binomial, okay, experiment. Sorry. Experiment. Okay, so all the 4 requirements are satisfied. Okay, now a second example is that a binomial experiment or binomial distribution. It said 8 different senators from the current US Congress are randomly selected without replacement, and whether or not they have what? Served over 2 terms is what is recorded. Okay, take note of that. Without what? Replacement. Okay, so let us go to the requirements. Well, first, we have what? The first requirement is satisfied because we have fixed number of what? Congress, I mean senators. So it has a fixed, the experiment has what? Has fixed number of trials. Okay, which in this case, number of trials will be what? The senators. Okay, number of senators, that's a fixed. 2, are the trials independent? No. The trials are not independent. Why? Trials are not what? Independent. Why? Because the selection is not, it's what? Without replacement. Okay, it's without replacement. Without replacement. So trials are not independent because, okay, selection is what? Without what? Replacement. Okay, then 3. Now, once you have that, you can conclude that this is not binomial, because for it to be binomial distribution, all the 4 requirements might be what? Satisfied. But I'm just going through the steps so that you see how I analyze it. Now, of course, each trial has what? 2 outcomes. What are the outcomes? Okay, a success is when what? A senator serves over what? Over 2 terms. So success, the success is what? A senator what? Serves over 2 terms. Okay, and the failure is what? A senator serves, is it over? That would be less or equal to, if it's over, that is 3, 4. Okay, so less or equal to what? 2 terms. And then, of course, the 4 is that the probability of success is what? It's not the same, because the success is affected by what? So again, the probability of what? Success is not the same for each trial. Why? Why? Because the selection is what? Without replacement. Replacement. Okay, it's without replacement. That's why. Okay. So that's it. So we conclude that this is not what? It is not a binomial. A binomial what? Distribution. Okay. All right. So that the 2 examples will tell you, one, it is binomial, the other is not, and why. So basically, because of what? The step 2 and step 4, we say that this is not what? It's not binomial distribution. But I don't need to get 2, just 1. If once requirement is not satisfied, then we conclude. Okay, so that's it. All right. Then there are more methods of finding binomial probabilities. In this case, we have a formula, okay, which is given by the probability of x, and sometimes we write it, the probability of x is equal, big X is equal to small x, okay. That if you have n trials, okay, and then you are selecting x of them, all right, that x could be takes from what? 0 to 0, 1, 2, 3 up to what? Up to n. So in other words, your x is less or equal to what? Is equal to n, but it has to be greater than what? Greater than or equal to 0. Okay, that's what we mean by that list. Now I wanted to note the formula is given by the n factorial divided by n minus x times factorial times x factorial. Now I want you to know this, okay? When we did what combinations, that is n combination r, okay? It's what was n factorial, n minus r factorial, and then r factorial. So if you replace the n, so r here with x, you get exactly what I just circled. And so the coefficient of n factorial, that term, that expression there, can be replaced by what? N combination what? X. So this is n combination what? X. And then we have probability of success raised to x times the probability of what? Failure raised to what? N minus x. Okay, so this is a combination because selection or that doesn't matter. Okay, that's why it's like that. Now, again, n is a number of trials, x is the number of successes, okay? And probability, p is the probability of success, and q, the probability of failure. And always remember, if you add the probability, the p plus q is equal to 1. Okay, so if you subtract one from the other, you get one, that one from one, you get the other, okay? All right. Now, let's consider this example, the trader account. Now, I just changed the probability, this probability to 80% or 0.8 instead of 0.85 because I want to be able to use a table to show you how we can calculate the probability. All right. So it says that when an adult is randomly selected with replacement, so it's very important. Replacement means what? They are what? Independent. There is 80% probability that this person knows what trader is all about. Okay, suppose that we want to find the probability that exactly 3 of 5, okay, 3 of 5 randomly selected adults know what trader is. Okay, is this a binomial distribution? If so, identify the what? The values. Identify the values. Okay, is it a binomial distribution? Of course. Okay, of course. What's the first one? It has what? N number of trials. Okay, n is equal to what? 5. So this is what? Fixed. It has a fixed number of trials. Okay, and what is the two? Second is that they are independent. Now, if you are the adults, the number of adults are what? Are independent, and so we have independent trials. Okay, independent trials. And then the third is that the probability of success. So your success S here is what? The adult, okay, knows, the adult knows about what? Knows about trader. Okay, they did this when trader was first became public. All right, knows about trader. And then the failure, okay, we use the capital F. The adult does not, okay, doesn't know about what? About trader. So when they ask them, they say that. Now, the third is that they are what? The probability of success remain the same. This is the independent. Why? Because it's with what? With replacement. With replacement. And then the last is that the probability of success remain the same. So the probability of success, which is P, is 0.80, remains the same for each what? Each trial. For each trial. Okay, so say identify the n, as we have said. So your n is what? It's 5. Your x, okay, in this case, your x is 3 because we have 3. Then when they sample them and ask them exactly 3 of them of 5, okay, your p is what? 0.8. And then your q is 1 minus 0.8, which is 0.2. Okay, so with this, we should be able to use the table, use the the StatCrunch, and use what? The formula. So I'm going to show you in the next given these values. Okay, so we want to find a probability that exactly three. Okay, in this question. So first we'll use the formula, we'll use the StatCrunch, and then the table. All right. Now, one thing about the table you need to note is that, okay, it has a probability of success P, and then the number, the N. If N is greater than 8, we cannot use the table because the table is limited. And then if P value is not one of the values included in the table, then we cannot use the table. Basically, we cannot use the table A1. So now let us go to, let's find a formula. First A. Okay, we know N is what? N is 5. P is what? 0.8. Okay, and then the Q is 0.2, as we indicated, and the X is equal to what? 3. Okay, so the formula is that the probability of what? X is what? Let me use the N combination X times the probability of X, P raised to X, then times Q raised to what? N minus X. So we want to find the probability of what? 3 is equal to, that is 5 combination what? 5 combination 3 times the probability of success, which is 0.80, okay, raised to what? 3 times the probability of what? Failure, which is 0.2, raised to 5 minus what? Minus 3. Okay, now which is basically 5 combination 3. Okay, if I do 5 combination 3, this is 10. Okay, and I have 0.8 raised to the third, and then 0.2 raised to what? 2. So when you evaluate that, this times 0.8 raised to the third, and then times 0.2 raised to what? 2, or squared. Now this gives me 0.2048. Okay. So the probability of getting exactly 3 out of 5 adults who know about what do you call it? Know about Twitter is that probability. So in this case, about 20.48% or 20.5, if you want to call that. Okay, so this is using the StatCrunch, and then B, sorry, using the formula. So using the formula is this. Okay, we have the formula, and then we want to use the StatCrunch, and then we also use the table. Okay, now let me do the table C first. So we want to find the probability of X, okay, which in this case the probability of what? 3. Okay, now using the same thing, your N is 5, your P is what? Okay, for the table, I need to know just the what? N, and then also X is what? 3, and then P is what? 0.8. That's what that I need for to use the table. And this is how the table works. Okay. So let me share my screen with you. All right, so here's the table. Okay, here's the table. Now the table, look at it. The first column, okay, the first column here is your N. This is your X. And these are the probability of what? P. All right, everything there is a probability of P in the first row up here. And then under each, if say if N is 1 and N is 2, X could be 0, 1, 2. If N is 5, we can have 0, X is equal, the random variable can take value 0, 1, 2, 3, 4, up to 5. Okay, so this is how the table works. Now, our question is that the N is 5, okay, which is this one. So N is 5. N is 5, which is here. Okay, that's N is 5. And then the probability of success, P, is what? Is 80. And then my X is what? Is 3. So 5, 3, and then where they coincide, so under the column 80, all right, and then under the column 80, and then x is 3, n is what, 5. What do we see? That is 0.205, 0.205. And so if you remember, when we use the formula, we got 0.204 for something. So if you run to 3 decimal places, we get the same what? The same answer. All right, so if you go here, all right, so using the table, this is what? 0.205. To 3 decimal places, this is to 3 decimal places will be the same. 205. Okay, so now let's go to how to use the StatCrunch to do the same thing. How do we use the StatCrunch to find this? All right, so I'm going to share my StatCrunch with you. All right, so that's a StatCrunch. Now here, what we do is that we go to the stat. This is the first time we're going to use this word calculators. Now under the calculators, we have different distributions. We have beta, binomial, normal, and then T, the Poisson, and others are there. In this class, we will concentrate on just 3 of them: binomial, the normal distribution, and then a T distribution. The normal and a T will come later in chapter 6 and 7, respectively, as we go. Okay, but for now, calculators, and then you select what? Binomial. So for binomial, my n in this, according to this question, n is what? N is 5. What's my probability of success? That is point what? 0.80. And then we want to find exactly, okay, you have less or equal to inequalities. You have greater than, less than, or greater than. Exactly is what? Equal to what? 3. All right, change that to 3 and then compute. Now look at that probability. Okay, the StatCrunch, the probability gave you what? Point exactly to 4 decimal places, exactly as the table we have in the table. Okay, that's we have in the table. And that is exactly what? 0.205. Okay, in 3 decimal places. All right. So going back to our PowerPoint, okay, using the StatCrunch. Okay, the probability that the capital X is equal to 3, or probability of 3, is what? 0.205 to 3 decimal places. Okay, so either we use what? The formula, we use the StatCrunch, or we use the what do you call it, the table. Okay, we will get the same what? This is the table value. We get the same results. Now let me go back and show you the table again, where we said that this table, if you have the probability P, you don't have your value or probability of success, it's not among these values here. It's not among these values, then we cannot use the table. That is one. Okay. If it's not here, then we cannot use the table. Secondly, if your n is greater than what? 8. Now this goes up to what? N equal to 8. So if you have n is equal to 9, then we are out of luck. Okay. So take note of that. Now let's go back to our PowerPoint and then look at homework problem number 6. Now here we cannot use the table, and what's the reason? I will show you in a minute. We have to use the StatCrunch. So let's go and share our screen. I'll stop sharing quickly, and then I'm going to look at 5.2 and then share my screen with you. Okay, so you should see my screen right now, 5.2 homework, and I'm going to do problem number 6. Okay. Come on. My computer is slow. All right. So number 6 is this. All right. It said that a pharmaceutical company receives large shipment of aspirin tablets. The acceptance sampling plan is to randomly select and test 37 what tablets, 37 tablets. Then accept the whole batch if there is only one or none that doesn't meet the required what specification, the required specification. If one shipment of 3,000 aspirin tablets actually has what a 5% rate of defect, what is the probability that this whole shipment will be accepted? Okay, so take note of that. Okay, our success is what? The success is when we accept the batch. So what is happening here is this. Okay, a batch of 3,000 aspirin what tablets. Then we randomly select 37 of them, and then we test it. Now, if we test and we have what? No, out of 37, no one that is bad. Or if we have just one that is bad, we accept the whole batch as what? Being good. Okay. Otherwise, we say it is bad and then we reject the whole batch, which is the 33,000 aspirin. Okay. So that is one way to look at it. Or if you have 37 tablets, if you have 36 or 37 of them being good, okay, then we accept what? The whole batch. Okay. Now you have to focus on either the defects, the number of defects, or the number of good ones. And I think it is easier to consider the number of defects because here you just need what? One of them or none. So if you had none means that then you have to test all the 37 tablets. Now, if I pick the first one and there is what? One tablet that is defect. Okay. And I keep going and I don't get any, then it means that I will accept the what? That tablet. But if you have more than one, then there is trouble. Okay. So how do we solve this problem? How do we find the probability? Okay. Now I want you to note, okay, my random variable is what? Getting a defects. Okay. One is defect. One or no defects. And the probability of success, it is what? 5%. Okay, we are focused on the defects out of the 37 tablets in that batch of 3,000 aspirin tablets. Okay, so if I want to do this, all right, I can open this open my StatCrunch. All right, I hope you can see this. I open my StatCrunch. All right, I have 37 tablets. My probability of success in this case is what? It is, so I get it, the number of defects, which is 5%, so 0.5. Now, it says that if we get what? 1 or 0, that means it is less than or equal to 1. Okay, now if you calculate this probability, that is what? 0.442. 0.442. Okay, focusing on what? The number of defects, that is your success. A fixed number, n is 37, your p is what? 5%, and then your x is what? Less than or equal to what? 1. That means x is equal to 0 plus x is equal to 1. Okay, that is one way to look at it. Or in the batch of 3,000 out of which sample 37, and if we get all the 37 are good or 36 are what? Are bad, okay, then we what? We reject. So in that case, the probability of success will be the 5% from 1%, which is be 95. So in that case, we will go, my n is still what? 37. Now notice that we'll get the same thing. This will be 0.95, but this time, if we get greater than or equal to 36, okay, then we should get the same what? The same answer. So 36 out of 37 are good, or all the 37 are good. Then we accept what? The whole batch. Okay. So in this case, the answer will be 0.442 to 3 decimal places. So let's go back, okay, and then enter the answer to 3. This says a 4 to 4 decimal places. That is, let me go back and check that. It is 0.418 to 4 decimal places to 4.418. Okay, let's making sure that you are seeing my homework now. Okay, so this is 0.4418, and that will be the one. That will be the answer. Okay, so now let's go back to the PowerPoint. All right. Okay. So again, why can't we use the table? Because in this case, I cannot use the table because my n, according to the example with the n is equal to what, 37, which is greater than 8. So we cannot use the table in this case, but I can use the formula, and that will give me the same thing. But using the formula will take some time. So, well, I can show you. The formula is that you have what? The probability of what? X. Okay, so the example that we did, our n is 37, our p is 0.05, and our q is 90.95. Okay, and then the x is what? 0 or 1. Okay, your success is the defects. Is the number of what? Defects in the 37 sampled. 37 sampled. So if I use the formula, we have the probability, it is 1, will be the 37 combination 1, probability of success, which is 0.05, raised to the x, in this case, which is 1, then times 0.95 raised to 37 minus 1, which is what? 36. Then plus the probability 0, okay, which is what? 37 combination 0, 0.05 raised to 1 times 0.95 raised to 37. Of course, 37 minus 0 is 37. So when you calculate all this, if you add this together, you should get the same answer as we got, 4.118 to 4 decimal places. Okay, that's how we evaluate that. Now, as we mentioned, finding the what, knowing the distribution, any distribution, we can find the center and then the spread. So in this case, we can find the mean and then the standard deviation for the binomial distribution. Okay, the formula, these are parameters. The mu, the mean, is given by what? The fixed number of trials times the probability of success, which is n times p. The variance is given by n times p times q. Okay, n times the probability of success times the probability of failure. And then the standard deviation, taking the square root of what, this guy here. And that gives you this. Okay, so let's apply this. Now, once I have this, if by the range rule of thumb, okay, if the value is greater than what? The mu plus 2 times the standard deviation, then we say that it is significantly high. And if it's less than what? Mu minus 2 times sigma, it is what? Significantly low. The mean is in the center, of course, as always. All right, so here's an example from the homework. Question number 7. Okay, assume that the different groups of couples use a particular method of gender selection, and each couple gives birth to one baby. This method is designed to increase the likelihood that each baby will be a girl. Okay, will be a girl. So when we get a girl, a couple gets a girl, that's a success. But assuming that the method was what? Has no effect. So the probability of what? A girl is what? Is this. Okay, so we have 50-50 chance. Okay, now assume the groups consist of 28 what? Couples, complete parts A through C. Okay, so what we have there, my n is what, 28, because of the 28 couples. What is the probability of success? It is what, getting a girl, it is 0.5. And so to find the mean, this is equal to n times p, which is what, 28 times 0.5. And that gives me 14. The standard deviation, sigma, is equal to the square root of npq. Of course, your q is also 50%. So the square root of what? 28, okay, times 0.5 times 0.5. Okay, you get 14, the square root of 7. Okay, which will give us 2.645. Okay, 2.645. Okay, so all right, so that gives me the part A. Part B, it said that the values of for certain value of girls or fewer are significantly what, low. Now remember, these are the limits, and I'm doing the part B now. Okay, that is mu minus 2 sigma, and then mu plus what, 2 sigma. So it means that I have, for the mean is what, is 14 minus 2 times, 2.645. Okay, what is that value? And then the second is also 14 plus 2 times 2.645. Okay, the first will give us 8.7, and this will give me 19.3. All right, so if you have a value, okay, that is the number of girls, if it is less than what, 8.7, then we say that is what, significantly low. So that what goes here will be 8.7, and this will be 19.3. So you have 8.7, less than that, it is what, significantly low, but if it's greater than 19.3, it is what, significantly what, high. Okay, so the question is that if you have this resulted in what, 22 girls, okay, is this significantly high? Of course. And then what does this suggest about the effectiveness of the method? Okay, so the result 22, okay, is significantly high. Is significantly high because 22 girls is greater than what, the 19.3 that we got. Okay, and let me change the colors. Seems you can see the what I'm writing here. This is 22. Okay, this is 19.3. Okay, then if it is so, then the result 22 girls will suggest that the method is what, effective. The method is what, is effective. All right, because out of the 37, right, out of 28, and you have 22 of them that resulted in baby girls, then we say that this is what, the method is effective, and it's the 22 is significantly high. All right, okay. Now, apart from using the range rule of thumb, that is within 2 standard deviations, all right, the tails, if you're in the tails, it is either to the right is significantly high, to the left is significantly low. We can also use the word probability to determine that, as we have been doing. Okay, so if you find the probability of what, X or more, and you compare with what, 5%, or sometimes it could be 1%, then we say that the X is significantly high. On the other hand, if you do probability of what, X or fewer, and then compare with what, 5%, it is less than or equal to, then we say that the X is significantly what, low. Okay, it's a low number of what, successes. All right. So here, take one example. Now, this is overtime in football. It is noted that between 1970 and 2011, there were 460 NFL football games decided in overtime, and 252 of them were won by the team that won the overtime coin toss. All right, they toss a coin. Now, don't forget, if you toss a coin, you have 50-50. Okay, so whoever wins out of 460, 250 of them who won the toss ended up winning the game and became a champion. All right. So the question is that is the result 250 wins in the 460 games equivalent to random chance, or is this number significantly high? We can answer that question by finding the probability that the 250 wins or more in this. That means we're going to compare with what? 5%. Now we want to assume the wins and the losses are equally likely. What does it mean? So here, our N is what? 460. My X is what? 252. And then my probability of success is 5%. That's why they're equally likely. So 0.5. And the probability of failure is also 0.5, a loss. Okay. So we can use the StatCrunch to calculate this probability, which I can show you in the StatCrunch in a minute. Let's go there. Okay, we have to put these values there. Okay, making sure that you are seeing my StatCrunch. All right, what is my N? N is what? 460. Okay, probability of success is what? 0.5, 0.5. And then we want what? 52, 52 or more. So that will be greater than or equal to 252. Now, what is this probability? Okay, this probability will give me what? 0.0344. So 252. I don't know why I put there 250. 254. Okay. So that gives us what? 0.0224 to 4 decimal places. Okay. So let's go back to the table. I mean the PowerPoint. Okay. Go to the next slide. Okay. So using the StatCrunch, as I showed you, we found the probability to 4 decimal places is what? Up. The probability is this value here. That is 252 or more wins. Okay, which is low. In other words, it is less than what? 5%. So we say that the 250, which is your X, 252, is what? Significantly what? High. That's one way to determine that. So this shows that it is unlikely that we will get 252 or more wins by chance. If we effectively rule out chance, then there's only one reasonable explanation, and that is the team winning the overtime, coin toss, has a better chance of winning the game. And so if I want to answer this, that whether the 252 is significantly high, there are two ways I can do that. Now take note of here, my N is what? Still 460. My P or my Q is 0.5, and my P is also 0.5. Okay, so if you want to find the mean, which is what? N times what? So the mu is what? N times P. That is a 460 times 0. Times half is what? The 230. Okay, that's why I got the 230. And then this is actually the square root of what? NPQ. You can check it out and see that you get this answer. But if I use the probability, okay, to determine whether it is high or low, okay, we find the probability of what? 250 or 2 or more, okay, and this probability was 0.0244, and this is actually less than what? 0.05. So we say that the 252 is significantly what? High. It's significantly what? High. Or we can do the two standard deviations. Okay, let's do the mu mu plus, let me erase that. Okay. Let's do the mu plus, or the minus. So the mu minus 2 times sigma, which is the 2, okay, 30, minus 2 times 10.72. Okay, this will give us, that's 208.56. And then we do the mu plus 2 times sigma, which is 230, plus 2 times 10.72. And that gives us 251.44. Let's say just 0.44. Now, of course, the 252, as you can see, is greater than what? 251.4. Therefore, it is what? It is significantly high. Okay, so that actually, bring us to the end of what this section. Okay, we look at the binomial distribution using the formula, using the scratch crunch, using the table to find the probabilities, and also finding the center, the mean, and the standard deviation, and then comparing and or determining that a value x is significantly high or low using the range rule of thumb or the probability to determine that. So that's it, and I'll see you in class next week. Thank you.